So welcome everyone. Going to just take a little quick attendance today, just to make sure got everybody's names correct. I think this should be recording by default. We're going to be recording all of these, just so you know. So if you miss something, it will be recorded. So I'm going to get you on camera saying hi, just so I'm going to make a little list and have people's photographs there. So just keep that in mind. I'm going to call on your name and just say hello, and then I'll catch you in the gallery, and then we'll get started. So let me close this up for now. So it will be really nice if you all can put on your cameras if that's convenient for you. It's just nice to see everybody and for us to see each other. If you're someplace where that's not convenient for you, I get it. That's okay. Also, yeah, if you've got your name in there, that would be great. And if I didn't do it here, but if you want to add some pronouns or something to your name, that's totally fine as well. You can tweak your name in case you're curious. If you go into the participations list, when you hover over your name and you click more, there's an option to rename, and I'm doing it now. I could say something like this. Okay, now I've got pronouns there. Okay, so yeah, when I call your name, please just let me know if you go by a nickname or if I mispronounce something. That would be great. So when you all jump into Zoom, just so you know, the settings in this class are, by default, you're going to be on mute. So just unmute yourself and say hello. So Maricela Aguilar. Oh,
hi.
hello. Nice to see you.
Nice
Welcome.
to see you. Hello. I'm kind of in a place where it's hard because I have a 10-month-old, so sometimes he's like a little crazy. So if you don't mind, I'm gonna mute myself and not share my video as often as possible.
That's no problem. I totally get it.
Okay.
No problem. Thanks.
Okay, thank you.
Yep. Brandon, Albert.
Yeah, no nicknames or anything, just Brandon.
There you are. Hey, Brandon. And let me see. So we got Brandon, Zara.
Hello.
Zara.
Hi.
Hey.
I just go by Zara.
Zara. Okay. Awesome. Nice to meet you. Wilfred.
Hey, I'm here.
Okay. Hey, Wilfred. How's it going?
Hey,
John.
how are you?
I think I saw you, John.
Hey, sir. Good to see you again.
Yep. Hey, John. Kaden.
Hello.
Hey, Kaden.
Hi.
You, Cheng. Sammy, I think is not going to be here today. He told me. Faye, how? Is Faye here? So in case you get, we have, usually we have quite a few students from China that come over who are unable to come over. So just so you know, we've got several classmates who are going to be taking this class from China. It's 4 a.m. in China right now. So we'll see how often they can make it. I hope they can. Yeah, right on time. 1 second. Hey. Thank you. Okay, you've all met my dog. That was Hazel. Hazel is here. Yanji Wang.
Yeah, hello, sir.
Oh, hey, Yangji. How's it going? So are you coming to us from China?
Yeah, it's 4 p.m. right now.
All right. We'll try and
It's
keep
not
you
too
occupied.
bad, I mean, yeah.
Okay, well,
Thank
welcome. Sorry about the time. Kevin, Jin, is Kevin here? Kayun? I think I've got that right. Kayun Kang? Molly?
Hi, Adam.
Hey, Molly, nice to see you again.
This is you again.
Hui.
Hi, I'm here.
Hey, Hui, nice to see you, sort of. Welcome, Victoria Martinez.
Hello.
Hey, Victoria. Dylan Matthews.
Hey.
Hey, Dylan. Heidi.
Hi.
Hey, Heidi. Nice to see you.
Nice to see you too.
Thanks. Giselle.
Hello.
Hey, Giselle. How you doing? Vasi. Last name is Riva. Vasi.
Yeah.
Alex.
Hi.
Hey, Alex. And Lindsay. Hey, Lindsay. Jaya Yu.
Hello. Hi.
Hello. Welcome. Brandon.
Probably me.
Oh, hey, Brandon. And Paul. Or Yukian.
Oh, hi.
Oh, hey, Paul. Or Yukian. Which do you
Hi,
prefer to go by?
Maybe remotely, but 4 a.m. is okay.
Okay. Gotcha. Okay. Well, that is everybody. I don't think I
think.
Yes. What's your name?
Stephanie Wade.
Did you add recently, Stephanie?
No.
Okay. Oh, yeah. No, I see you right here. You're in the right place. Sorry, I skipped right over your name. I feel so bad. Welcome. Thank you, Stephanie, for letting me know. Okay. Well, great. So welcome, everyone. We've got about 24 students in the class. And before we get going, I'll introduce myself in a second. That should be fair. But we also have an LA for the course this semester. So for those that aren't familiar, an LA is learning assistant. And so this is typically an undergrad who's taken the class and done well, and will help us out, will help you out during the semester. So we do have a learning assistant, Nat, who is online with us. Do you mind just saying hello, Nat?
Hello, everyone. So my name is, you can call me Pham. I'm a senior majoring at in economics at UC Denver. And for this semester, I just want to tell you one thing. Please come to my office hour, since it's really helpful from you guys and really helpful for me too, because you guys gonna wake me up in the mornings. And I hope you guys have a wonderful semester. Thank you.
Yeah, thank you, Nat. So Nat has been a student of mine in at least one class and has LA'd for me in the past, not for this class, but in stat theory. So you're in good hands with Nat. So I'll take us through some of the slides to make sure you're aware of where you can contact Nat and myself outside of class, and kind of go through the logistics of the class first today, and then we'll get into the content towards the end of class. So I'm sure you've got some questions about how the class is going to be structured, since different teachers are likely to be doing this differently. Okay, so let me let's do this. Okay. Okay, so here we go. So yes, so my name's Adam Spiegler. So welcome, everyone. I made a little intro, may not have watched it. So in case you're curious about my story, so I've been here at CU Denver for 3 years, coming from Loyola University in Chicago, before that for a long time. And so I came here a couple years ago. I'm the director of the undergraduate program here. So you may have seen my name in some emails that go out to the majors and minors, and I'm also the undergraduate advisor. So I have either had a number of you in class already or come or interacted with you with advising. So it's great to have you in class. Yeah, my office hours this semester are going to be online on Zoom. So in case you're kind of curious, our Zoom location, our classroom is going to be the same for the whole semester. So this link is going to be the same. You can bookmark it or whatever to make it easy to find. My office hours, I do want to point out, the Zoom is different here than our class. So just be sure you don't try and pop into the classroom for office hours. And so my times for office hours are Tuesday, midday, Thursday mornings, and I am happy to meet you at some other time if those don't work. I will just let you know, Mondays and Wednesdays are a little bit more crowded for me, but a Tuesday or Thursday or a Friday should be able to work something out. So please, like Nat said, please do take advantage of this. It's a great opportunity for us to just get to know each other as well. So if you want to contact me outside of Zoom, definitely email is the best way to go. I'm online all day long, so I'll get your message and respond back. And Nat's Zoom link is also different from mine. So here's where you can go for office hours with Nat and his times on Tuesdays and Fridays from 10 to 11. And here is Nat's email as well. Okay, so let's first talk about the grading and how we're going to be using our time on Zoom together. So during this semester, we've got 3 exams. Each are worth 20% of your grade. So altogether, exams are going to make up 60% of your grade, and then we have kind of assignments throughout the semester that'll make up 40% of your grade. So the 2 exams during the semester are tentatively scheduled, so you can find those dates on the syllabus in Canvas. Exam 3 is going to be during finals week, which has not been set officially yet, so just be sure you're not taking off totally for finals week. This exam is not going to be a comprehensive final exam, so that's why it's weighed the same as the others. So it's really 3 midterm exams throughout this semester. And so in addition to that, we'll have homework due pretty much most weeks. And then most classes are going to have a little brief, what I'm going to call a reading quiz in Canvas. And I'll show you what that looks like in a moment. So kind of the workflow is going to be that these homework assignments are longer. You need to write them up and upload your work with all of the details shown. Those are going to be due on Mondays at 11:59 p.m. So just before midnight on Mondays. That should be every Monday. So I like to kind of keep these things scheduled just so you guys can plan accordingly. So Mondays, y'all have homework due. Monday at 1:45, Wednesday at 1:45, you'll have these quizzes in Canvas. Any questions about that? Okay, so let me give you a quick little tour of our Canvas site, since different instructors might structure their page a little bit differently. Okay, so here's our page. Hopefully you guys can see it as well. And so most of the information is located in the module. So I like to organize things in the module. So after this week, the course homepage is going to be the modules instead of that welcome. And for each week, you're going to roughly organize your materials like this. So there'll be readings, there'll be things that we do during Zoom, and then there'll be some things that you're going to be doing outside of Zoom. And then there's the homework. So I kind of group things into those clusters. And so for today, we're going to be going through, here are the slides that you're looking at. So I think it might be helpful to go on before Zoom starts, and you can download the worksheet that we're going to do for the day, for example. So we will work on this in a moment. So if you want to download that now, so you have it handy, or you want to print it out before class starts, that might be a good idea. So anything that we do during Zoom is going to be posted. I record these meetings. I'm going to upload the recordings as well. So you'll be able to catch anything that we do during Zoom. And then outside of Zoom, there'll be some component of watching some things asynchronously and working on the quizzes before we come to class. So let me just say the gist of the quizzes, maybe quiz is like the wrong word. It's really an assessment, and you've got multiple chances to get it right. So it's not timed. You're not being graded on your first attempt. You've got 3 attempts to get the questions correct. So the idea is there are some ideas that I'd like you to think about before you come to class so that we can build on them during class. So what I kind of worry about in the Zoom environments is that we would spend time in class going over the basic stuff, and then you would have to do homework that might involve some challenging stuff that we hadn't gotten a time to think about together in class. So I'm going to try and put the materials that I think are more straightforward that you would be able to work through on your own time up ahead of time, so you can come to class kind of with the basics, and then we'll delve deeper into that during class together to talk about some of the more challenging parts of those concepts. So the quizzes are not going to be the most difficult stuff that I'm going to throw you out there to figure out on your own. The quizzes are really intended to be some of the more straightforward things that I'm hoping you can pick up at home. But of course, that might not be the case, and you're always welcome to ask me some questions. So let me just show you what the quiz looks like. So this one is due before Wednesday's class at 1:45. So there's a little indication here about what sections from the textbook is on this quiz. So the quiz that you guys have for Wednesday is on sections 2.1 and 2.2. So you can read this and try the quiz. Maybe just reading it is enough for you. If you like to listen, particularly to me, then you can listen to these videos. So I tried to make videos and I broke them up into like 5-minute pieces. The idea is reading that and or watching the videos should set you up to do the quiz without too much trouble. So the quiz deals with statements. What is a mathematical statement? So it's just a bunch of multiple choice questions. This one has this has 8 multiple choice questions. And I'll just say the first 5 are pretty much would have been one question, but I have to break things up separately in Canvas. So it's really like a 3-question quiz.
Are the quizzes, when you take one, is it final, or do you give like 2 attempts?
Yeah, so I'm going to do this one real quickly. So I am not reading anything. I'm going to say this, that, this, that, that. This is not how I'm intending these quizzes to go, by the way. This is the exact opposite of the intent. But I'm going to submit all this. You might see what some of the answers are. I might get lucky. And so this tells me, actually, I got one of them right, all the rest of them wrong. And it tells me the correct answer, which is weird. That wasn't my goal. So I might have to change. So it shouldn't tell you what the correct answer is. You should have multiple attempts to do this. So this does say that you have 3 attempts in which to do it. It might just be showing the correct answer because I'm the teacher. You shouldn't see what the correct answer is until after you're done with it. But you've got 3 attempts to do this one, and some of them have only 3 parts, so you definitely should get them right. That's not the point. The point really is not to assess you or grade you, but to give you some practice before we come to class. So that's where the quizzes are, and that's what they look like. And the homework is posted as well. And like I said, this is due next week at 11:59 p.m. So most of this is just the instructions. The actual homework assignment is on this PDF file. And so I would prefer if you all could upload your work into a single PDF file. So you definitely do not need to type things. You're welcome to just write them out on paper like you would if we were meeting in person. And then you can take photos of each page. And there are various apps. You might be familiar with some of them, but there's like an Adobe Scan app, which is free. That does a really good job of taking a series of photos, merging them together into a single PDF. So if you do have any trouble with the technology side of getting your work uploaded, just let me know. But the idea is you would write it out, and when you're ready to submit, just click the submit button and then upload your file and click submit assignment. Questions about that? So the homework is going to be graded by either myself and or a grader. The Canvas quizzes, they're going to be graded automatically in the system. Okay, so I think that is all I wanted to show on Canvas, but are there any questions before I unshare Canvas? Okay, so let me get back into the slides then. Okay, so we got our exams. Yes, so the textbook is free. I should have showed you that link, but hopefully I've sent a couple of emails out that had it attached, and it's on our Canvas site as a PDF. I bought one because I'm old school, and this is what it looks like as a hardback. This was 20 bucks. I got it from Amazon. So if you do want a paper copy, they're relatively cheap on Amazon, but certainly if you're happy with the PDF, then you're done for the semester. There's nothing else to purchase. Just be sure you get the right edition. This is the 3rd edition of the textbook, but that's the one that's up in Canvas. If you go to Canvas, you'll get the right one. Okay, so yeah, so as far as what's going to happen in Zoom, yeah, please make sure that you've got the right name, because that's what I can see tagged with all of you. If possible, if you can't have your mic, your cameras turned on, that's great. Your microphones are going to be on mute by default when you join. And so just please keep them on mute unless you're talking, or else we'll hear the barking dog or other things in the background. And so when you do have a question, please do stop me. I'll just say there are chats in here, and you're welcome to use the chat. It's just when I have an iPad over here with my slides and I'm looking at all your faces and I'm talking, there's just a lot to process reading the chat at the same time. So you're welcome to send things into the chat. Just be aware that I probably won't catch them until I have a break in talking, which is fine, because usually I stop every so often and say, are there any questions? And that's when I'll read the chat. So if you do have questions and you want me to see it right away, like you can raise your hand. I can't see all of you at the same time, so I kind of rotate between the class. But there is a raise hand icon on the side in the participants. So if you have a question, you can also click on that. That also is hard to see sometimes when I'm going and I'm talking and annotating slides and so on. So I don't care if you unmute yourself and just say, hey, I have a question, and stop me. That's totally fine. Okay. And so as far as the cameras go, I'm not trying to get invasive into your space by any means. It's just, it's really difficult when you're teaching. We need all of the data that we can get to connect with our class. And so getting those visuals from you, whether it's like, you know, those faces are great. It's helpful to see that, and I can see it. So it's just nice having that interaction. So with each other as well. But if you do have any concerns about that, I get it, and just let me know about it. Yeah, and then I think the very last kind of logistic thing that I want to talk about is what happens if Zoom crashes. And I don't want to say if. It is like we're going to be meeting each other a lot. It's very certain that it's going to crash one day for me while we're online, or for you as well. When it crashes for you, I suppose it's not as big of a deal. When it crashes for me, it's going to be a big deal because you're all there and counting on me. So I just want to say that if it crashes, I think you should be able to stay in Zoom. I don't think it will close for you. So if that's the case, just stay in Zoom. It's probably something that I can fix in about 2 minutes, and I'll be back on. If it's something that's more severe and I'm not going to be able to rejoin you, I will try and use the Canvas announcements as a way of updating you on what my situation is. Hopefully, at least my phone would work so I could send that in. If for some reason it crashes and everybody gets kicked out, I will restart it right away. So please don't go too far away. And if it happens for you, usually the trick is log out and log back in, and that works 99% of the time. So just don't give up. Just log out, log back in. You might want to try and restart your computer. That usually fixes the problem. If the problem is you don't have an internet connection, then I think downloading the app onto your phone is a good backup plan. It would use your data plan, which might not be ideal, but at least you could still connect over your phone. Okay, so are there any questions? Okay, so want to take a look at that worksheet. That was worksheet called Worksheet 1. I'll open it on my iPad. So it's called What is Proof? And so these are the same problems that are on the slide. So this has a totally empty page back here, but it has 4 statements. And so, yeah, so what are we going to then be doing? This might seem like a weird name for a class, Introduction to Abstract Mathematics. So what we mean by that really is learning some skills for writing mathematical proofs. And I'll just say that it's quite different than like solving calculus problems. So I will say, like, a lot of mathematics, we have algorithms for things, and we have step 1, step 2, step 3. We can work through a problem. I'm not going to say that proofs are totally not like that. I'm just going to say, you know, every proof is going to have to be approached maybe slightly differently. So there's not going to necessarily be, here's a foolproof plan for solving every mathematical proof, but to kind of build some flexibility in tools that you can use for different situations. So we'll be talking about different methods of mathematical proof. You may be totally new to this. You may not have had to prove many things in your previous math classes. So it's really just a logic and a philosophy class, almost more than anything else. So we're going to use some different interactives in here. So I'm hoping this time in Zoom, for a good portion of it, can be spent with you all working with your classmates and discussing problems. Since I think when you're learning how to write proof, sometimes it's equally important to not be sure whether the proof that you're hearing is true. So I want you to have some time to talk with your classmates and think, is what this person is telling me correct? And critique each other's reasoning. Yeah, there's a question. Maricela?
Yeah, so I was wondering, just because like you said, it's different from calculus and stuff. So
Mhm.
is there any prerequisites to this course?
I think the prerequisite for the class is Calc 2.
Alrighty, cool.
Yeah. And to be honest, we're not going to be doing too much, calculus in the sense of calculating derivatives and integrating things. But towards the end of the semester, we will use some of these techniques that we've learned to revisit and prove some things in calculus that you might have been taking for granted, that we can go back and revisit. So yeah, certainly like ideas of continuity, differentiability, these things will come up in the class.
Sounds good. Thank you.
Yep. Any other questions? Okay, so I'm gonna break you guys up into some breakout rooms. So for those that are familiar with Zoom, you may be really familiar with these things. If you haven't used Zoom much, all that means it's gonna randomly shuffle you up into groups of 3 or 4 students. And then you'll be taken out of this main room and just put into a private Zoom with like 3 or other students or so, where you can discuss these ideas. Nat and I are going to try and poke in and just check in on the different rooms and make sure that you're making some progress. And then the idea is to have you guys talk about these for some time in your groups, and then we'll come back together and talk about them as a class and wrap it up. So very open-ended idea here, which is, here are a number of statements. So I'll just take number 3 since it's the shortest one to read. So for every integer n bigger than 1, 2 raised to the power of n minus 3 is not divisible by n. So that's a statement, right? And we'll kind of refine this a little bit, but this part over here, that's either true or that is false, right? It can't be somewhere in between. And so the idea is, okay, well, how can we prove or disprove that that statement is true? And so here the idea is, well, this was checked computationally by a computer up to 1 trillion, and it seems to be working. What can we say about this statement in general? Can we say that this is going to be true in general or not? So these are the types of ideas that I would like you to discuss with your classmates. There's no right necessarily or wrong answer here. So before I split you all up, yeah, there are these 4 statements that are on that worksheet. So again, you might just want to make sure you've got that worksheet handy. When you go into your breakout rooms, you're welcome to share screens with each other. So if one person has this, you could share it with your group mates. Any questions on the task here? Okay, so let's do this for 15 minutes. And if you guys wrap up your discussion, please just like chat away and get to know your classmates. That's totally fine. But I would like you to at least get through talking about some of these problems before you get sidetracked. And just so you know, that Nat and or I might pop in your room. And so you randomly might see somebody appear. And I've got just a couple of poll questions here. So one question. So this is in regards to the first statement about the area of, or the sum of the angles in that polygon. And so how many, just trying to gauge your belief of that first statement. You're free to differ from what your group said when you were all meeting with groups. And if anybody has any questions, please feel free to, I can read the chat now. I've got that open. Okay, so here's the results. We got just about everybody in. So let me share them with you. So you guys can see the results? Yeah, okay. Yeah, so let's see. So they varied all over the place. We have a pretty interesting distribution. So if we do the math here, most people said it was true that you, or at least that you believed the statement. And some thought the explanation was fine. Some thought it was mostly fine. And some thought, I believe it, but I don't think their explanation was clear. Yeah, and you're free to chat in your thoughts. They'll just come to me and not to everybody else. But it's useful for me to gauge your thinking. You're totally welcome to throw in your random thoughts on the chat. I actually enjoy that. Yeah, and so I think some of the things that came up, and if anybody wants to add something else, just start chatting in, start talking is fine. So this is a true statement. And I'll just say that I think this would probably fall into a category like true, but we're missing some details here. So this can be seen by adding diagonals to the polygon. Well, there are all sorts of other diagonals that I could try and draw, right? And there are other triangles that I can draw. So like here are two triangles and a rectangle in the middle. Is that what you meant, right? So there are different ways that we could create more familiar shapes out of this. And so they're not exactly clear about what's going on. And so it might have been more clear to provide like, okay, you can start with any vertex, and it doesn't matter which vertex you start with. And this is a pentagon here. This has 1, 2, 3, 4, 5 sides. And so the reason why I can get these n-2 triangles is because I can pick one vertex and then draw a line to every other vertex that it's not already connected to. And that's going to be n-2 other vertices. And that's where these n-2 triangles come from. So now I can see, I got 1, 2, 3 triangles, n was 5, I've got n-2 triangles.
Can I ask you a question about that?
Yeah, of course.
So since the statement says you have to form n-2 triangles, does it really matter where the diagonals go? Because you'll end up with the same amount of triangles either way.
It doesn't matter. I'll just say that if you're trying to build a systematic way of like saying, why can I always get n-2 triangles? This is one way to explain how you can always get n-2 triangles. There certainly are other ways that you might want to explain that. But I think that does need to be explained. How can I always, like, what is the process for doing that?
Okay, thanks.
Yep. Yeah, and definitely almost all of the problems we look at this semester going to have different ways that we can justify things. So I don't have a justification in mind necessarily when I'm looking at things, but I do want to make sure that all of your steps are being justified when you're writing things out. Any other comments about that first one? Okay, so let's open this up again. Same question, but now it's referring to the second statement with Newton's second law. Okay, so take another 5 seconds to get your vote in. Okay, so here were the results for Newton's second law. So Again, most people thought it was true, though less people believed it this time around. And kind of the people that thought it was true had various ways of thinking about this. So not to put anybody on the spot, just voluntarily, for somebody that said they did not believe this statement, do you mind clarifying, like, why don't you believe this statement? You're welcome to chat it in privately to me if you prefer, or you're welcome to speak up.
I'll take the heat.
Yeah.
So kind of the position I took on this one is that with what's demonstrated on the page, it's not, you know, a proof, and that, you know, it's kind of the idea that it may have been proven in times, but if it's disproven on that n+1th time, then it's no longer true.
Yeah, so I will say that maybe 2 and 3 might kind of fall into similar buckets in that they were checked with experimentally, right? I mean, basically, statement 3 is saying we checked this with experiments up to n equals a trillion. The statement 2 is a more well-known statement, Newton's second law, than the third one. So maybe there's some attachment to like Newton. This is in just about every physics book ever. Seems pretty well established. And so I'll just say this is not necessarily true all of the time. Again, there are some details that have been left out. Does anyone know like when this actually might not be true?
It is not in a Newtonian frame of reference.
If they're not in a Newtonian frame of reference, what do you mean by that?
Generally, a proper Newtonian frame of reference uses the center of gravity of the entire system. In our cases, that's essentially the center of gravity of the sun in order to base all of your measurements off of. The measurements we do using the Earth or other things are relatively valid for the small scale we're doing them on, but you start getting either atomic scale and smaller or bigger than the solar system scale, they're no longer valid. The error is introduced in them.
And so who fixed those issues?
Einstein,
Hawking, and a handful of others.
Yep, that's right. So we need to be careful about this. This is true most of the time when like you're living on Earth in a normal situation. But yeah, like things like the speed of light and other issues, this law starts to deteriorate a little bit. That's right. And it wasn't until maybe 100 years or so ago that Einstein was particularly interested in when does this stuff not work. That's right. Yeah, so yeah, so that there's that one. So any other comments on 2? On question 3, won't open up the poll here, but at least the couple of discussion rooms that I went into, the discussion was pretty similar about this one, which is we can't say it's not true. Seems like it might be true, right? So we haven't gotten any evidence at this point to say that it's false. But the question is, this is saying for every integer. And so the question, I don't know why I'm not writing, might be, well, just because we check the first 1 trillion, that doesn't mean every, right? And in fact, this is not true. 4,700,000,000,000,000,000, no, sorry, I was off. Nope, that's right, 4,700,000,000,000,000,000. I think I'm missing some zeros here. It fails at about 5 trillion, I'll just say that. So it's good up to about 5 trillion, but then it fails. This was found out not so long ago. So that was something that people thought might be true, but then we figured out that in fact there are some counterexamples. So something good to point out there is that all it takes is one counterexample. It's much easier to prove that something is not true than it is to prove something is true, right? To prove something's not true, you just need to find one bad thing. To prove that something is true, finding a trillion things that it works for is not sufficient. Okay, and last one, I want to see what you guys think about the fourth statement. So here, what I'm asking you is, do you believe statement number 4 is true? Okay, take another 5 seconds, please, for responses. Okay. So here we have, let's see, 12 people said yes, 8 people said no, or I'm not sure. This statement here actually is not correct. This was believed to be true for a very long time, for about 100 years. At the end of the 1800s, somebody came up with a counter example. They found a function which is continuous everywhere, but not differentiable at any point. So in other words, if you think about differentiability, right, it's usually like these corners that cause problems. So when something has a corner, it's continuous but not differentiable. So someone was able to construct a function that was basically just a bunch of corners connected to each other, but at no point even is there a line connecting things, because a line would imply that something is differentiable. Does anyone know who came up with that counter example?
I'm going to go with the safe guess and say Euler.
Good guess. So Euler was actually he was around at the same exact time that this result came out. He was a little bit before 1806. So in case you're curious, I'll just take you over.
Was it Leibniz or?
It's not Leibniz. So Leibniz, he's one of the discoverers of calculus along with Newton. And so kind of the idea was that Newton and Leibniz, they came up with these ideas for calculus in late 1600s. And they checked it, like Newton's second law. They had all of these experiments that said, hey, all of the things we're doing in calculus, it seems to make sense. But nobody was certain whether it made sense or not until about 1900. So people were doing calculus for 200 years just based on a whim that it works out. And it wasn't until 200 years later, when people started doing real analysis, that they were able to firm up the foundation. And so if you're curious about the counter example, it's called the Weierstrass function. And this is what it looks like, if you can see this over here. And in fact, it's kind of like a fractal thing, which is what they're trying to show here, is that when you zoom in on each of those corners, you just see a bunch of other corners and a bunch of other corners and a bunch of other corners. And they have a nice little video about how this thing is constructed, if you're kind of curious about this. But here was another kind of situation like question number 3, which was, this was something that was checked for a lot of things, but once we find one counter example, that's enough to override 1 trillion things that did work out. Okay, so I will stop here since we're out of time. I will just say that if anybody wants to talk about anything after class ever, I don't have anywhere to go after class, so you're welcome to stick around. Otherwise, be sure to, so on Wednesday, you've got section 2.1 and 2.2 to look over before class and take a little quiz on those 2 sections. And then in class, we'll do sections 2.3, 2.4, 5, and 6. So we're going to come back to chapter 1 later. We're going to start at chapter 2 in the reading materials. Okay, sorry for keeping you a couple minutes extra. I'll let you go a couple minutes early on Wednesday. But nice to see everybody, and have a good day. Good luck with your classes, and I'll see everybody on Wednesday.